This is lesson 10.3a, operations and monomials in prealgebra. And we're getting deeper and deeper into algebra as we continue on with this book. And the first term that we're going to look at real quickly is called a monomial. And mono means one. And what it is, it's one term that is either a constant, like the number 3 is a monomial, or the product of a constant and one or more variables. So 3x, putting them both together with multiplication, that would be a monomial. I could also write 3x squared, y to the 4th power, z to the 5th. Because they're all multiplied together, they would be considered a monomial. And a lot of times, just for the most part, a way to tell whether something is a monomial or not is look and see if there's a plus or minus sign on either side of it. So if I have 3x squared and let's say I have 7y plus 2x, if I were to just look at this part, that would be the monomial. Okay, so it gives you a little bit of an idea, not a really huge deal for you to understand that completely or to know what a monomial is or recognize that all the time, because you're usually just going to use them, not necessarily name them. So there's two basic steps involved when you're multiplying monomials. So we'll go ahead and go through those. First of all, we have a monomial like that. This right here is called the numerical coefficient, because it's a number. So that's a numerical, why did I put an O there? Coefficient, I'll just write that. And then the x is just the variable. So we can call this, basically, we're just going to call that 3 the coefficient. You don't have to say numerical coefficient. But anyway, let's go ahead and start multiplying some of these things. Example 1, we've got 3x squared, and we're going to multiply that by 4x cubed. Alright, so the secret behind multiplying monomials. We multiply the number parts, and then we multiply the variable parts. So we follow the rules that we've learned all along through the course and just take them one at a time. So we're going to take the 3 and the 4, the negative 3 and 4, and multiply them. Then we're going to take the variables, x squared and x cubed. And remember, when you multiply exponents, you add the exponents. So negative 12x to the 5th power. And that's it as far as multiplying those. And so let's go and look at the second part of this example, example 1. And it gives me 4/5. Of course, they're going to give me fractions here, times y squared. And I don't know why in the world they're using multiplication signs in here, but we'll put them in here. And they want us to multiply those. Alright, so what I'm going to do here is I'm going to put these together. I don't need that silly multiplication sign there, so I'm just going to make it y squared. To me, it just makes it confusing, because you don't need it when you multiply. When you put the letters beside each other, that automatically means multiply. Alright, so what we're going to do is we're going to multiply the numbers. 4/5 times 10, which we're going to multiply the 4 times the 10 and get 40. And then 5 times, this is over 1, so 5 times 1 is 5. So 40 over 5 is going to be 8. Multiply the x to the 5th and the x cubed, and we add our exponents. And then y squared and 1y, so we have 2 y's and 1 y, gives me 3 y's. And we're done with that one. Example 2 has us doing some division. So let's see if I can get rid of this stuff here. 15x cubed over 3x squared. So we're going to, again, do our division of our numbers first. 15 divided by 3 is 5. And then when we divide exponents, we subtract. So that's 5x to the first power, or just 5x. Alright, when you look at b, we've got 39x squared y cubed over 3xy to the fifth. So 39 divided by 3 is 13. And then x squared over x would be x to the 2 minus 1, which would be just 1, or you don't even have to have it there. And then y cubed over y to the fifth would be y to the 3 minus 5. So we have 13x, y, 3 minus 5 is negative 2, which means this is in the wrong place. And we usually want to have our exponents positive, so we're going to put that y in the right place, which is in the denominator position, and we get an answer like that. So for example 3, they give us 25a to the fifth b cubed by 50a squared b squared. So again, we look at the number. 25 over 50 reduces to 1/2. And notice I just made a long division sign because some of these numbers will go on, or variables will go on top, some of them will go on bottom, depending on how things are. So when we look at a to the fifth over a squared, it would be a to the 5 minus 2, which would be 3. And since the bigger number is on top, the answer is going to be on top there. And then we look at b cubed over b squared. 3 minus 2 is 1. So we have b. And when we have it like that, we don't really even need this 1. Anytime there's a 1 multiplied by something, we can just take it off. So our answer is actually what I have right there. A cubed b all over 2. So notice my answer is different than the book's because when I was looking at the book I didn't realize that this was a b to the 7th. I looked at it as a b squared. But anyway, this is the right answer compared to what I did here. And if this were a 7, it would look a little bit different. It would look like the one in the book. So let's jump into example number 4. So when dealing with multiplication and division of numbers written in scientific notation, there's a pretty quick and easy way to multiply something that looks this nasty. And the first thing we do is we just multiply our numbers together here, our first numbers. And then we look at our numbers with exponents. And since they both have a base of 10, we're just going to write the 10 here. And then we combine the 7 and the negative 4. Now remember, when we are multiplying exponents, let me see if you can see through my mess here. I've got this whole 4 times 10 to the 7th times 2 times 10 to the negative 4th. So these are just next to each other, so that's obviously multiplication. What do you do when you multiply with exponents? You add the exponents. 7 plus negative 4 is going to be a 3. And that's your answer. So not too bad. When we have a division such as 9.6 times 10 to the 12th, like in example 5, and we divide it by 3 times 10 to the 4th, we divide our numbers, 9.6 divided by 3, and when we do that we get 3.2 times 10. And then we look and see what our 12 are. We've got a 12 and 4. When you're dividing with exponents, you subtract, so that would be 12 minus 4, which would be 8. And that's what you get when you do the division. So, not too bad there.